Okay, so guys, I'm going to run through again torque, what it is, how do we calculate it, how do we solve for net torque or a missing variable if an object is in what we will call rotational equilibrium. So guys, some of you may already have this down from yesterday. If not, don't worry. I'm going to go over it, which can only help you for the quiz that you're going to take. So in order to get an object to turn, okay, we need to apply what we call a torque, which is basically a rotating force. So it's a force that is a certain distance from the pivot point. So this black dot is our pivot point. The distance this thing is away from the pivot point is r. So torque is equal to, now they may write it out like this, perpendicular force, that's the symbol for perpendicular. It's perpendicular force times r, which is your lever arm. Lever arm is the distance from, all right, your axis of rotation, sometimes called the fulcrum, but I'm using P, pivot point, to where our perpendicular force is. Now, torques have two directions, either clockwise or counterclockwise, okay? Now, when you do this, so what I'm going to show, I have it written on the board and at the top of your paper, but I'm just going to simplify it because on your test, or I'm sorry, on your quiz, you're only going to be dealing with two central directions. So your pivot point will be basically this black dot, the most central part of a clock. Now a clock goes from 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So like the drawing here all the way to the left, if the pivot point is here and the bar extends out to the right, it would be like, okay, pivot point's here, bar extends out to the right.
Good up.
Okay. Now, if you have a force that is going to push down here, that would push the time hand, right, on a clock from 3 o'clock to 4, 5, 6. That is the correct way time moves, so we will call that clockwise. If it is going, the pivot point's here, the bar extends out to the right, and if we had a force like this, that one would be counterclockwise. So a force that would try and turn the time hand, all right, to force time to go not the correct way, from 3, 2 to 1 to 12 o'clock, that's not good, okay? And then the 9 o'clock version, pivot point here, extend it out to the far right, okay? A down arrow will cause this hand to go from 9 to 8 to 7 to 6. That ain't it. So that is counterclockwise. And over here, an up arrow is clockwise. Okay. Pretty much, that's what one of the first things that you're going to need to do is to determine the directions. Force, all right, the direction of their forces on these guys, whether it's going to be a clockwise or counterclockwise. Now, then they showed us a problem. Okay, so you're going to have two problems on your quiz. One is to find a net torque, and one of them is to find, all right, basically either a missing force or a missing lever arm distance for an object in rotational equilibrium, which we will get to. All right, so in this one, if the pivot point was here, so if you weren't here yesterday, place this dot here. Okay, here's your pivot point. Again, the R value, the lever arm value, is the distance from the pivot point to where your forces are. Okay, so if we find the pivot point, what would my first thing be? Determine the directions. So if I put P here and I have extended out to the right, that would be like, here's my pivot point. If I extend out to the right, any force going downward would be considered clockwise. Any force going upwards would be considered counterclockwise. So counterclockwise, counterclockwise. On the way back, a downward force will be considered clockwise. So CW, wait a minute, Mr. Lombardo. Do I put this one as CW or do I cross this one out? Yes, you're going to cross it out. And the reason why is if a force is on our pivot point, there is no R. There is no lever arm value. There's no distance. So you won't be able to produce a torque. No, you're just going to cross out the force because this 2.0 is going to help us because this 2 meters is how far our 9 Newton force is away. So we've labeled all of our forces. We've canceled out this guy. All right, I wrote it here. If a force is on the pivot point, the torque produced is 0, and you can cross it out. So the next thing you're going to want to do is calculate their torques. Torque is equal to, the force times R, the lever arm. So let's do all the clockwise ones first. There's only one, and what value is that force? 5 newtons. Now, how far away is that 5 Newton force? Well, it's 2 meters plus 7 plus 4. So 7 plus 4 is 11. Okay, 11 plus 2, 13. So this thing is 13 meters. Okay, you would need to multiply that out, and when you do, you get 65. Newton meters is the unit for torque. Are there any... All right, now I'm just going to put a little check marks next to this one because I know I've done it. Are there any other CW forces? Clockwise? No. So we're good. Now we're going to go on to the counterclockwise. First one I come across from P is the 9 Newton. How far is this 9 Newton force from P? Correct, 2 meters. So we got 18. And then the 4 Newton force. So a couple people on the quiz today wrote, they just said 7 because they saw that little distance there. Okay, well, the 4 Newton force is 7 meters away from the 9, but it's also this additional 2 meters. So how far is it away from P in total? 9. So this 4 Newton force is 9 meters away, which gave us 36 Newton meters. Okay, now, we did this one and we've done that one. Are there any other forces going involved here? No. So what do I do next? Just like, all right, this is an old school, this is a throwback. If I can find this, I guess I'll just use this piece right here. If this was 5 and this was 10 newtons, and you had a force in this direction of 20 newtons, and I asked you guys to find the net force.
It's 5 newtons to the left.
It's 5 newtons to the left. So 5 plus, if they're in the same direction, you add them, like what we have to do right here. So same direction, we add them. And that comes out to be 54. All right, so basically you would be then, if we simplified this, you'd have 15 newtons this way and 20 this way. Now, if you have 2, all right, forces in the opposite direction, what did we do with them? We subtracted to find the net. So you're always going to take the bigger number minus the smaller number. So what's 20 minus 15? We said 5. And then what would the direction be, to the left or to the right? To the left, because the left side had the greater value, the greater magnitude. So very similar with torque. This is the total clockwise torque. This is the total counterclockwise torque. So we need to basically figure out which one's dominant and which way this thing is going to rotate. Is it going to rotate clockwise or is it going to rotate counterclockwise? 54, I added the 18 and 36. So in this case,
Subtract.
65 minus 54, and that gives me 11 Newton meters. So the net torque is 11 Newton meters, and in what direction? So which value was the larger of the two? Was it the counterclockwise?
Clockwise.
Correct. It is the clockwise. The 65 is greater than the 54. So to receive full credit on your quiz, you're going to basically need to do what I just showed. Okay, force times however far away it is. Okay, figure out your total of that one. If there's multiple, then you have to do the multiples. Add them. Once you have the total clockwise and counterclockwise, you subtract to get the remaining value, and then the direction it's going to be, whether it's CW or CCW, is depending upon which one had the larger value. Since 65 is greater than 54, the direction will be clockwise.
But if you just take out that,
No,
oh, that would be such a question.
that would be too easy.
That would be so clutch
Too easy!
if you did that.
No!
I'm not, so like, it would be easy.
Quit your lying.
Oh, you gotta
Quit your lying!
Let's do test now, so let's press my brain.
Okay, well
Yeah,
let
for
me
real.
get through the other problem that's going to be basically on there.
Screw that problem. I could do 50.
Oh, you think you're going to be able to do this one? Yeah. Okay. So we would say that this is example 3. We did example 1 yesterday. Example 2, all right. I'm going to show you guys example 3 because this is basically almost identical to one of the problems on your quiz.
Try to tell us the same problem.
It's the same problem, different numbers. All right. So this one's not drawn in for you, so we got to draw this in. Pivot point, it's going to be all the way to the right. We're going to label that P. They say that this whole thing is 2.6 meters long. All right, bet. Now, one of the things from the notes that we had used, all right, that would help you with this part is that any object that is a geometric shape, right? Square, rectangle, sphere, triangle, the center of gravity or the center of mass is located at its center point. So at the very, very center would be the concentration of the weight of this object, of this 920. So I'm going to look and I'm going to find approximately the center, and I'm going to draw a straight line down, arrow. This is a 920 Newton force. All right, this is the weight of the object. So remember, if this 920, guys, is in the center, and the whole thing is 2.6 meters long, and what is half of 2.6? 1.3. So that means that this side is 1.3, and so is this side. Now, you don't necessarily need to draw this one in over here, but I'm just doing it anyway. And they said, okay, well, how much force are you going to need to lift this, all right, to lift this railroad tie on its axis, right, on its pivot point, lift up and rotate this thing uniformly so that it's not super accelerating one way or the other. So we are looking for this F, this force. So if an object is in what we call rotational equilibrium, all right, if it is in rotational equilibrium, now to lift this thing just straight off the ground at a constant value, you would need 920 newtons worth of force. All right, that's quite a bit. All right, it's like 200 and something-ish pounds, I believe, roughly. So we want to figure out this. We're really using this one. In which case, you have to set both torques equal to each other. Okay, so what is the clockwise and what is the counterclockwise feature? Well, if our point here, our pivot point here is like the center hand of a clock, it goes out to the left, like to 9 o'clock. And so an up arrow would push time from 9 to 10 to 11. That is the correct way time moves, so that's clockwise. The downward force would try and push this 9 o'clock to 8, 7, 6. Not the right way, so we're going to call this one counterclockwise. So guys, what is the equation for torque again? The 920? Because, yeah, when the pivot point is here, like on this thingy, so the pivot point is there, and then it goes out to the left. An up arrow is going to be clockwise. A down arrow is counterclockwise. So since our pivot point is here to the left, down would be counter. Okay. So what is the equation for a torque? Force times R, which is your lever arm. What is R again? Lever arm is the what? The distance that the force is from your pivot point. Okay, so let's see. Do we know what the CCW force is?
F1R.
920. Okay, do we know how far this 920 Newton force is from the pivot point?
100 meters.
Very good. Now, we don't know what this F is, so we're going to leave it as F. And do we know how far F is from the pivot point?
2.6 meters.
Very good, 2.6, right? Because it's all the way at the other end. So, guys, this is it. And then solve for F. So what would I do? I'd have to multiply this side. So 920 times 1.3 is 1196. That equals F times 2.6.
Oh, so you got that 1.3 from like having 2.6?
Correct.
I'm confused for a minute.
It's all right. That's why we ask our questions. So how do I get F by itself, y'all? Got to divide by. Yes, sir. Divide by 2.6. And so when you throw that into a calculator, 1196 divided by 2.6. 1196 divided by 2.6. So the force is equal to 460 newtons. And that's all you would need. I don't need the direction for this one, all right, because we already had it labeled. So that is one of your problems.
Oh, I'm stupid.
No, you're not. What'd you mess up?
No, I wrote this thing on this. Like,
It's all right.
On the wrong.
That's fine. We're not going to go crazy with the other ones. We're not going to go crazy with the other ones. Okay, so I'm going to give you two more examples. All right, two more examples. These ones, if you guys have a separate sheet of paper, you may want to use to just kind of draw them out, and we're going to do them, and then we're going to take our quiz. Okay, they're going to be done. They're very, very similar. Okay, I'm going to make them identical, again, with different numbers. All right, so I would definitely get a sheet of paper out. Guys, shh. Okay, please. I'm recording this, so stop. Alrighty then. We'll say that this one. Let's go with. What's a good number? 10, 12, 15. Let's go with.
I like 4.
Nah, we're going to go a little. 14 is fine. We do 14. Okay, and the only other thing that the drawing has on your quiz that this doesn't have. Okay, so we want to find the net torque. You want to find the net torque for this. Two 26 meters. All right. So what you guys want to do is figure out your total clockwise torques and your total counterclockwise torques. One of the rules is if you are on the pivot point, can you cause rotation? No, because torque is your perpendicular force times R. Well, if you're on the pivot point, you have no R value. It would be 0, and anything times 0 is 0. So guess what? You would do this on your quiz first thing. Cross that John out. Bing bong. Yep. Now, on the board, you have this. Okay, you have your 3, your 9 o'clock, 12 o'clock, 6 o'clock. Down on this side and up on this side are both clockwise. Down over here and up on this half is counter. So first thing you guys are going to want to do is identify who is counterclockwise and who is clockwise. So let's start. Go to the pivot point. And if this is my pivot point and I go to the left, it's like 9 o'clock. All right, so I'm going to pretend like all this half isn't here right for a second. Pivot point, going out to the left. An up arrow is clockwise or counterclockwise? Clockwise. So I'm going to write a CW above that. Are there any other forces on this half?
Yeah. No.
Nope. Cool. So then go to this side, this half. All right, so the pivot point's here. It goes out to the right like it would go towards 3 o'clock.
That would be counterclockwise.
Which one?
14N would be counterclockwise.
14N, very good, because it's pointing up, so this one is a CCW. And the 15 is going down, so that is a just clockwise. Very good. Okay, and now we just need to figure out, all right, the rest of our pieces of information. So what do? Let's do want to do the clockwise ones first? Okay. So 10 newtons is clockwise, so I'm going to say 10 newtons. How far is this 10 Newton force from P?
13 meters.
Well,
No.
No.
Hold on, I know.
It's like 7 meters, right?
Okay, so right here, from P to this end is 13, but then you go back 6.
7 meters, right?
Yep, so 13 minus 6 is 7. So this distance is 7. So that's how far the 10 Newton force is from P. So we're going to do 7 meters. So this is 70 Newton meters. Do we have any other, and I'm going to put a check mark next to it to make sure I know it's done. Do we have any other clockwise forces?
15.
The 15 newtons, so I'm going to write 15 newtons. And how far is this guy from P?
7, right?
It's 15. Wait. No. More than 6.
7. It's not 7. It's the same distance.
Yeah. It's split in half.
Because right here, right? So the 26, if from here to this side they tell us is 13, that means
It's 13 on that side.
this side, this whole side has to be 13. And the same thing, if we go back this way, 6, 13 minus 6 gives me this distance here of 7. So this 15 newtons is only 7 meters away from the pivot point. So 7 times 15, or 15 times 7, 105. And then we just going to, are there any other clockwises?
No.
So then we can just add them up to get our total. I get 100, correct, 175. Oh, sorry, let me zoom out for a second. Whoop. Okay, so the next thing that we need to worry about is our counterclockwise. And that force is 14 newtons. And how far is 14?
7.
7?
No, it's 13. Because the 6 is on the top, right?
Remember, right? So 20.
With the 1 with the 7.
I'm on fire, Mr. Lombardo.
You are. Absolutely. You're crushing it. So 26 is the full length. This half was 13, which means this whole half also has to be 13. And since 14 is all the way at the very, very end, that is why it has to be a distance there of 13. Yep. So 14 times 13 is 182 Newton meters. Are there any other forces going on?
No.
No, so we're good. So now we need to find the net. Always then take the higher number minus the lower number. And what do we get? 7.
Oh, actually 7?
7 Newton meters.
Oh.
And in what direction? Who is the bigger direction?
Right.
What?
Right. Oh,
What?
counterclockwise.
Counterclockwise. Thank you. So that would be, this would be how you get full points. Okay, you get a point for the calculation, point for this answer, point for the calculation, this answer. If you need to add them up, boom. Point for this calculation, this one.
Can we keep this?
Subtract, get the right number, unit, direction. And then we will do just one other one, and then we will, as the Black Eyed Peas said, let's get this party started. For this value right here? Okay.
I'll explain. I got it. You see how the 6 is down there? That's what, you didn't even write 6. That's on the bottom, it's on the top, so that means that is 13 like that.
All right, ready? Here, look. So I wrote here that the full length of this thing is 26. You see that? So this whole distance is 26. If the pivot point is right there, and from the pivot point to this end, this complete end is 13, that means if I didn't know what this side was, I would do 26 minus 13, and that would give me this whole side. So 26 minus 13 is 13. So since this 14 is all the way at the end, this 14 is a total 13 meters away from P right here. That's where the 13 came from. Now, if you were trying to figure out where the 7 is, well, if this half was 13, right, this half was 13, but then you have to come back this direction, 6, 13 minus 6 would tell me that this remaining piece had to be 7, which is where we got these guys from. All right, same thing on that side. All right, and now the other problem is all right, P here. We got a bar going out to the right. Let's say let's go with 4.4. So this whole thing is 4.4 meters. All right, if we have a giant piece of wood, a rectangular piece of wood, and that thing weighed, we'll use my age, all right, 34, but we'll times it by gravity. So we'll say that this thing here is a total of 340 newtons.
We're using your age, so like
34 times 10. We use 10 for gravity just to make calculations easier. Whatever. So you get this. Remember, where is the center? Like the center of the board is where all of its weight is considered to be concentrated. So if 340 is at what we would call the center, how far is the 340 from P?
Wait,
If
half of 340?
no, not half of 340, but
No?
half of this.
2.2.
Yes.
I think that half.
So
Oh,
this
yeah, because that's meters. That's just.
correct. And then so basically they're asking, okay, well, with what force are you going to need to lift in order to get this thing to rotate uniformly? So in this problem, you are going to set the torques equal to each other. So like the hand on a clock, decimal here. Does this extend out towards 3 o'clock or 9 o'clock?
3 o'clock.
Towards 3 o'clock. Right? So towards 3, which means the down arrow is our clockwise fella. And the up force, counterclockwise. So you have 3 of the 4 missing things. So since we have 3 of the 4, right? I think we do, right? Well, let's find out. If this is CW, let me figure out that stuff. The force is 340. How far is this 340 from P?
2.2 meters.
Correct. And now over here, do we know what this force is?
No.
So we're going to leave it as F. But do we know how far F is from P? 4.4. Very good. So you're going to multiply 340 times 2.2, and that comes out to be 748. And that is going to equal F times 4.4. How do you get F by itself? Divide by what?
748.
You want to divide by 4.4 to get F on its own. So 748 divided by 4.4 comes out to give us a force here of 170 newtons. Yes, you may. All right, guys, so that basically those two questions, different numbers, are your quiz. Okay? Those two numbers, or those two problems with different numbers are the quiz.
Can we keep this?
Sponsored by Alpha Anatomy.